In this video, we're going to look at example 2, where we understand rational exponents. So in part A, what is the meaning of the exponent in the expression 16 raised to the 1/4 power? Just bear with me on this. This isn't exactly how you would do this normally, but I want to kind of show the process of, the thinking behind this. So we have the expression 16 raised to the 1/4 power. All right, and I'm going to rewrite this in a couple of different ways and just kind of break it down so we can understand what's going on and create a rule that we can follow moving forward with these types of problems. So what I can look at this as is something to the 1/4 power, right? So 16. 16 I can rewrite in various different ways, right? You have like 8 times 2, 16 times 1, 4 times 4. But what I want to do is I want to write it, in this case, I'm just going to show the work. All right, so if we were to multiply these, this would be 16. So 16 is the same as 2 to the 4th power. All right, and that's shown here. I think that's pretty easy to understand. Well, the powers of exponents tell me that a power raised to a power, right, these will get multiplied. So these two should be multiplied, and 4 times 1/4 is just 1. So this becomes 2 to the 1st, or just 2, which is the same, and we learned this in the last video, 16 to the 1/4, 2 is equal to 4, the 4th root of 16. I remember that one we did up here in part B. Okay, so these are equivalent. Now, you wouldn't normally go from like here to here. That's not something you would normally do. But just for the sake of this problem, we're showing that those are equivalent to one another. All right, so let me get rid of that. So all we're looking to show here is that in general, all right, and in general, if you have anything, so in this case, let's say x raised to the 1/n power, which is the same as this, then that is equal to the nth root of that value of x, which is this over here. All right, and you can see that that 1/4 and the 4 is kind of on the outside there, and you could even think of that like as a 1, inside there. All right, that's all we're looking to do. That's what we're trying to show, is that this is your rule here. All right, so focus on this. That's the whole point of example 2, part A. In part B, what is the meaning of the exponent in the expression 27 to the 2/3 power? Well, for this one, there's 2 different ways I'm going to show this, and I'll show you how quickly one of them is a much better option than the other. Using the same idea of x to the 1n power can be rewritten as the nth root of x, what I can do for this specific problem is I can rewrite it in 2 ways. I can take that denominator, the 3, and I can say that this is the 3rd root of 27 raised to the 2nd power, or I can say it's the 3rd root of 27 raised to the 2nd power with that square on the inside. Both of these are the same. All right, you can use either one of them, but what you're going to find is that usually, and this doesn't apply to every single problem, this one on the left is going to be easier because it's pretty easy for me to find the cube root of 27. I don't need a calculator for that. All right, what times itself 3 times gives me 27? Well, that's going to be 3. All right, so this becomes 3 squared, which is just 9. So this is my answer. Over here, I don't even know what 27 squared is. So I would have to find the cube root of whatever 27 times 27 is. And quite honestly, I don't feel like doing that. So although I could do that in this problem, this first process is clearly a better option. So what this shows is, let's see, what letters am I going to use? I'll try to stick with the same. Let's say m and n. I can rewrite this as the nth root of x raised to the m power, or x raised to the mnth power, is the same as the nth root of x raised to the m power. All right, so either one of these works. These are the formulas we're looking to understand and know. So make sure we're able to go back and forth between these two, here and here. You're probably going to find that one of them works better than the other in a lot of problems. So hopefully, although that might seem a little confusing, I think if you just kind of break it down piece by piece and keep asking yourself the right questions and understanding that, I do think you'll be okay with this, especially when you get to actual problems where you see here you have 25 to the 1/2. If you put this into action and apply these rules, you'll understand it pretty well.